Hello students, welcome to Shourabh Sir's classes. So in today's video, we'll be solving a question from mathematical statistics. So the question goes like this: the random variables x and y are independent and both have uniform distribution on 0, 1. Let z equals to modulus x minus y. So we have to prove that real theta and z comma theta is equals to 2 into expectation I theta minus 1 minus I theta divided by 1 theta whole square. So we have to deduce the expression for expectation z to the power n. So how do we do it? First, we'll have to draw a diagram. For this, what we have to do is we'll draw this diagram. We'll take the origin 0, we'll take x here, we'll take y here. This is nothing but y equals to x, and this is nothing but 1 comma 1. There we'll have 1. So now here we can write y is less than x and here y is greater than x. We can write this. Now from here what we can do is we'll simply write down phi theta comma x minus y equals to limit 0 to 1 e to the power I theta modulus x minus y modulus f x comma y dx dy. So we can do this. Now from this we can do what? We'll take limit 0 to 1 and in the bracket we'll incorporate this inside the bracket, so it will become bracket 0 to, instead of 1 we'll write it as x e to the power I theta x minus y dy, and we'll take it inside a bracket and we'll write dx. So answer would be 2 by n plus 1 n plus 2. So this is going to be the answer, 2 by n plus 1 into n plus 2. So in today's video we solved a question of mathematical statistics. In the subsequent videos we'll solve other questions. So thank you for watching this video. I'm asking you to go through this for at least couple of seconds, then we'll proceed further with another sum. So we'll go further with another question. So in this question it is given, if x has an exponential distribution with mean 2, the probability x less than 1 given x less than 2. So how do we do it? For this we simply have to write down the probability x less than 1 given x less than 2 is equals to 1 minus e to the power minus theta which is divided by 1 minus e to the power minus 2 theta, where theta is equals to half. So we can write it. So this is the answer for this question. Now I'll be giving you a couple of seconds to go through it once, then I'll go to the next one. So I hope you guys have gone through it. Now I'll go to the next question, which is this question, that is find limit of this. So we have to find this thing. How do we do it? For this to do, first we have to write down Pn equals to probability 1 minus 1 divided by root n less than equals to summation xi minus mu whole square divided by n minus sigma square. So which must be less than equals to 1 by root n. So minus sigma square, which must be less than equals to 1 by root n. So first we have to write this. So now this must be equals to probability of minus root n less than equals to summation xi minus mu whole square minus n sigma square less than equals to root n. So now if you further solve this question, we'll find it to be equals to probability minus 1 less than equals to root over summation I equals to 1 to n curly bracket xi minus mu whole square minus sigma square divided by root n less than equals to 1. So we can write this way. So now further if you simplify it, we'll get the value to be equals to P, that is probability minus 1 less than equals to Sn given root n less than equals to 1. So similarly here Sn equals to summation I equals to 1 to n curly bracket xi minus mu whole square minus sigma square, which is equals to summation ui. Now similarly, and ui is equals to, or this is I'll write it as mu y. So mu y is equals to xi minus mu whole square minus sigma square, where I is 1, 2, 3 dot n. So I belongs to 1 to n. So now we'll need to take another page. So here what we have to do is we'll simply write down expectation of ui is equals to expectation of x minus x bar, instead of x bar we can simply write mu whole square minus sigma square, which is nothing but sigma square minus sigma square, which is 0. Now we have to find the variance of mu I. So variance of mu I will be variance, curly bracket, first bracket, xi minus mu whole square minus sigma square, which is equals to variance of xi minus mu whole square equals to expectation xi minus mu to the power 4 minus expectation xi minus mu whole square equals to sigma to the power 4 plus 1 minus sigma to the power 5. So instead of this, we can also, instead of mu, we can write it u. So it was u. So similarly we get this value. So the value will be equals to 1. This gets cancelled out, so we are left with 1. So now we'll further solve this. So if you further solve this, you will get the expectation of Sn to be equals to summation I equals to 1 to n expectation ui, which is equals to 0, and variance of Sn equals to variance of summation ui, which is equals to summation variance ui equals to n. So similarly, now if you apply the formula of CLT, hence by CLT we get Sn minus expectation. I am expecting you guys know about CLT. Sn root over variance Sn, which is equals to Sn divided by root n. Similarly, this tends to n 0, 1 as small n tends to infinity. So what we have to do is, this finding we'll write as double star, and the previous finding that we had found in the earlier page, this as first one. So now if you solve this too, with this we can get limit Pn n tends to infinity equals to limit n tends to infinity minus 1 less than equals to Sn divided by root n less than equals to 1, which is equals to probability minus 1 less than equals to z less than equals to 1, where z tends to n 0, 1. Now if you simply put the value, we'll get it to be equals to 2 into p belongs to 0, z tends to 0 to 1, which is equals to 2 into 0.3413. So we get the value to be 0.6826. So we have solved this question. Now we'll go to the question again. So we had to solve limit this. So we have found the value to be equals to 0.6826. So if you guys have any query or doubt regarding this question, I'll be giving you my number, which is 9836793076. You can simply WhatsApp me on this number. You can also go to our website, which is www.showropsirsclasses.com. There you will find a lot of other videos like this, and you will also get to see a lot of other materials which are needed for mathematical statistical question papers. Thank you for watching this video. Have a nice day ahead.